Hello everyone, we are here at OFC 2026 in Los Angeles, and I'm here with Ryan at TeraHop booth. Good morning.
Ryan, nice meeting you.
You have 6 exciting demos, and I think for me personally the most exciting one is XPO. I think you have really great performance when I look at the performance stats here. Can you walk us through the demo?
Yeah, sure. Yeah, so holding in my hands actually is the industry first 12.8 terabit per second brand new XPO module here. There are a few really very important innovation here. One is this is the industry largest capacity pluggable transceiver ever, right? We're talking about 1.6 T ramping up. This is jumping to 12.8 terabit per second. This is really producing a highest capacity, but also highest density. This is packing 48 times the 1.6 T transceiver in one.
Yeah. So what's the gain in density that you have if you compare that to?
Yeah, so from density point of view, you basically are producing a 4 times more faceplate density.
Yeah.
What that means now you can pack a 200 terabit per second capacity switch into one OU. It used to take 4 times high, tall switch form factor. Now it's collapsing into just one OU. Yeah. So in a scale-up applications, you're going to need lots of connectivity out of GPU to have that scale-up domain. You really are collapsing the switch rack density from like 8 racks to 2 racks. So that's really great saving for the scale-up applications.
That's impressive, and it looks almost error-free, right? I mean, if you look at the
yes, this is probably the first ever fully functional XPO transceiver running 6 channels, live carrying BER going through, and practically error-free. This is prefab error-free. So this is really tremendous performance.
Very impressive.
Yeah.
Very impressive.
Yeah. And another thing is liquid cooling. It's actually very important. This is also the first ever pluggable transceiver with liquid cooling built right inside the module. So what that means, you can actually, maintain this very high capacity, but relatively cool temperature. And what that does is you can actually maintain a very high performance, but also relatively mild temperature inside. So all the components are lower power because like laser, for example, you're running in cool conditions, it's lower power. And then performance and reliability also important because when you're running component cooler, reliability also improve a lot.
Yeah. So especially when you have that faceplate density, right? And then you get the temperature down to bits.
And that's actually come with the whole package of system design, right? Not only you producing this dense form factor, but the system design allow you to have this kind of very dense but liquid cooling. So you can actually using the same module, not only for scale up, by the way, you can use it for scale up, scale across. You can pack a lot of technology inside because now
you have read time now, but you can LPO.
Yes, so all that variance is going to come along pretty quickly, right? We already actually developing the half retime, unretimed LPO, fully behind this module, and also the coherent coming, right? So later on, we're going to talk about Coherent Lite, because this can cool up to 400 watts. So you keep it very low power for scale up application, but you can also support much longer distance with higher performance optics because it had a built-in cooling capability.
Yeah, excellent. It's exciting. I think we need it. We need more capacity. So I think this is...
Yeah, we're excited about this new innovation here.
So now we look at TeraHop's NPO live demo. Ryan, I think also exciting. This is part of the Open CPX MSA. I think, this year we have the OCI, we have XPO and the Open CPX MSA. I think that's good that we see more interoperability between vendors, and this looks also pretty cool. So tell us about it.
Yeah, so with the speed really continue to go up, capacity really continue to increase. It's important to make sure the open ecosystem is enabled in our industry to enable the wider deployment, right? So TeraHop is a founding member of this Open CPX MSA. So our goal is to basically offer a common form factor connector system, a interoperable ecosystem, allow the end customer to actually deploy them. So TeraHop team up with Coherent, Sienna, Marvell, Samtec, Molex, we all come together to basically form this MSA. I think it's one of the industry first 6.4T to start, but then we have opportunity to continue to grow. So holding in my hand is industry first 6.4T. This open CPX connector compatible NPO system. So this is actually the starting of that journey of open up the ecosystem to implement not only NPO down the road, we can actually also, depends on the customer, open up substrates or interposers. We can actually mount this in different variety of applications. So it could be NPO, could be CPO, depends on how customer like to do so.
Because there's a lot of discussion around serviceability. I think CPO, NPO is very attractive in terms of low loss and co-packaging. But then the question is on how do you service it? But I think the open CPX is detachable, right? So it's not.
Yes. So this is holding my hand. You can see there's a connector here. This is a high-speed connector. This is a little bit lower speed connector. But combined together is an open defined spec. So the end customer can service this easily because it can unplug from their board when they need to repair. But also, even during the manufacturing process, right? You can actually individually test the NPO, and then you can install it and individually test them without binding together at a very early stage, co-packaged with a very expensive ASIC. If anything yield goes bad, now the very expensive unit goes out. So this is actually allow also very economical deployment of these optical engines.
So you basically can have the known good device approach, so to say that.
Exactly, and serviceability too. If you need to repair, you can, check them out one at a time. You don't need to service the whole very expensive units. Yes. And we're actually doing live demo here. You can see this is, again, I think a very first connectorized NPO, 200 gig per lane, but showing very impressive BR levels. We're talking about 10 to minus 10 BR floor. Yeah. I would say you look at the floor, probably this is one of the most impressive demo you can see.
Excellent, very impressive, very impressive.
Thank you.
So we looked at XPO and NPO, those were all 200 gig per lane. And right here we have a pluggable transceiver with 4x400 OSFP. I think last year you showed one single channel and now you have a full 1.6T 400 gig per lane transceiver.
Yeah, this is the first time industry now see a 4x400G 1.6T full transceiver with both the transmitter and receiver. We're showing here with Keysight equipment to display the eye diagrams. Basically getting very impressive TDC here. You can see T.Q is 1.2 dB.
That's impressive.
So this is actually pretty significant progress from last year. And this is also the first time to put together the DSP, the optical X, to demonstrate the full performance. And there we are also showing BR floor there, actually better than 10 to minus 6. So again, this is a very good link end-to-end performance. I think that's probably the first time industry actually displayed this level of, I would say, full transceiver performance. And if you look at the FEC tail, so to speak, it's actually stay like up to 5.6. So this already demonstrates a great promise of the 400G per lane technology moving forward.
Yeah, very impressive. And you have the DR4 here. Any plans for other reaches for 400 gig per lane?
Certainly, once we demonstrate the capability, there will be other options. FR4 going to be one of the immediate options, like doing the 4 WDM coming in. The distance probably going to go roughly about, I would say, less than a kilometer. So go to 400G, you're going to need, next technology, which is Coherent Lite. We can discuss later, but we're going to cover a pretty wide range of applications with 400 gig per lane.
Very good, very impressive. Thank you.
Thank you.
So OCS is also a large point of discussion here at the show. And last year you had 64 by 64. This year you demonstrate 300 by 300 in a full system, very low loss, which I see to build large scale-up networks. Very impressive.
Yeah, thank you. Yeah, we made a lot of progress on OCS front, right? Last year, we are showing pretty simple low channel count, but now we are upgraded to 300 by 300. Both type of OCS will find application, but certainly customer are demanding larger port count, so they can actually build really large scale up pods, so to speak. So this is important progress for the industry. And we also started really go up to the system stack, so to speak. So actually, there's a full software behind that we call a NOS. So it's that networking operating system behind the switch box. So that can present API to end customer to really control, monitor, and maintain operational for the whole switches. And you can see very low loss. So this is less than 2 dB typical. So this is actually quite impressive looking at the industry.
Yeah. Very
No
impressive.
benchmarks.
And I think it's for scale-up networks, but I think there are also other use cases, right? I think there's a...
Yeah, so people find actually new use once you have the new capability presented to customers. So you can use it for like a spine layer switch as well, replace the packet switching to save power and save costs, as long as you can manage the traffic. And you even see people start to use this for protection switching for the scale across, like, string together multiple data center buildings, and you can use OCS to reconfigure for reliability or even for directing traffic if you need it.
Yeah, I mean, yesterday at the executive forum, we also heard that building the system is as much effort as building the chips, right? And I think this is a big part.
Yes, that's the overall theme. We are more and more a solution provider than a component supplier, because we need to be really well aware of what the customer environment is and build up the whole system, make sure that solution is really fitting nicely.
Very nice, thank you. Anthony, so we talked about scale-up network, scale-out, so now scale across, you have your 800 ZR Lite. Talk about it.
Yeah, so industry is building these AI clusters bigger and bigger, and not only just one building, now it's multiple building. Meta is talking about Manhattan size data center, and you're going to cross pretty great distance for these AI pods. So coherent technology used to be very long distance, OCDAN, purpose built, now really start to come into data center campus. And this is industry first O-band Coherent Lite, actually ready to get deployed soon within this year to next year. And even though we start 800 gig, but it's a precursor, we're going to go to the next generation, 1.6T, 3.2T, because there, with the baud rate going up, you're going to see significant challenges in dispersion tolerance, in link budgeting. So Coherent Lite is going to be a big help when it comes into the next generation deployment of data centers.
Yeah. And then there was a lot of discussion, or is a lot of discussion of your traditional DCI and scale across. Can you talk a little bit about that?
Yeah, the traditional DCI really is interconnecting data centers, but much more facing customers in different locations. But when we talk about scale across, really it's a cohesive AI cluster built for training inferencing. So it's a very different requirements with latencies, with coherencies. It's actually very different construct from the traditional. But look at the physical layer, they do share a lot of, I would call it technology heritage, right? The ESP processing capability, the coherent domain, core technology itself. But now we need to scale much bigger volume, right? Traditionally, several 100,000, we are talking about tens of millions of these transceivers need to be built in the Coherent Lite technology. So it's going to require much more improved economics and scale of production. So we are getting ready for that.
Yeah, Ryan, you talked about a solution portfolio. So here we have another option, so to say, for customers, 10 kilometer reach, IMDD for scale across networks, 1.6T OSFP, very impressive.
Yeah, thank you. So we really need to develop solutions, not only just one area, but really across the spectrum, right? Scale up, scale out, and now really, data center is so big, so you really need to help customer, especially 1.6T is ramping up. So we're going to need to get ready. They're going to deploy inside data center first, but soon they're going to start to interconnect these data centers. So this solution really addresses them pain point. Like you now need to interconnect all the data center buildings together with much bigger range, right? So this is actually a relative newer technology using LAN WDM running at 200 gig per lane. So you can pack the wavelengths a lot closer, so you can overcome the dispersion limits of at least 10 kilometers of fiber. So you can really piece together all these data center in a very meaningful but very cost competitive ways at 1.6T.
Yeah, very impressive. So you everything really from scale up, scale out, scale across. You have a whole solution portfolio and can mix and match with technology as well. I think it's impressive. Yeah? So that basically you have all the building blocks and whatever the network should be, you can build that as a really solution provider.
Yes,
Very good.
that's what we intend to do. Thank you.
Excellent. So more interconnects are moving to optics, especially if we look at scale-up. That's all copper today, but I think optics also goes into the scale-up network. Here you show PCI Express with both active electrical cable, but also optical.
Yes, so what we see is with the AI infrastructure built up, you start to see lots of custom-built infrastructures, right? With their own accelerators, with their own architecture, how to build these fabric, both for training, but more and more go to inferencing. So they may require different type of fabric to interconnect different pieces of compute and even storage, even memory, even other networking gears. So we are doing our part to basically build a connectivity solutions to these customers where they actually use PCIe as a protocol. And we can build both the electrical domain and optical domain. So they can, for example, the active electrical cable can go 7 meters. So this is actually one of the industry records as well to go that far. And then optics, obviously, you can go 30 meters or 100 meters. So that gives customers that freedom to construct their AI compute fabric.
And you can extend beyond the rack, right?
Yes. So this is go within the rack, between the rack, even like much bigger, their own clusters.
Excellent.
Yeah. Thank you.
Thank you, Ryan.
Thank you so much.
Good meeting you.
Appreciate it.
Very
Yeah.
good.